Hello friends, I'm back again with a new video in the series DSNL Go for coding interviews. The problem that we'll be solving today is reverse linked list from position M to N. So we are given a linked list as an input and we have to reverse the portion of list starting at position M till position N. Now let me try to explain the problem statement with the help of an example. Suppose this is the input list that we are given and we have to reverse the portion of the list starting at position 2 and ending at position 4. Okay, so if you count the positions, so basically this is position 1, position 2, position 3, position 4 and position 5. So we have to reverse the portion of the list starting from position 2, okay, this node, and ending at position 4. Okay, so the result will look something like this. Okay, so we have reversed this portion of this linked list. Let's now discuss the approach to solve this problem. Okay, so basically I have divided this approach into three steps. Okay, so in the first step we'll basically reach the M node. Remember, we have to reverse the portion of the list starting at position M and ending at position N. Okay, so in the first step we'll basically reach node M. Okay, but we also need to keep track of the M minus 1 node. Okay, so basically this can be easily done with the help of a previous pointer. Okay, so where you basically iterate till node M and you have an additional pointer previous which points to the previous node of M. Okay, so we will keep on iterating till we reach M and this previous pointer will point to M minus 1th node. Okay, then in the step 2 we'll basically reverse the portion of the list between position M and N. Okay, so as you can see in the picture that we have reversed this portion of the list. Okay, during the process of reversing we also need to keep track of the nth node, the end node for the portion to be reversed, and we have to keep track of n plus 1 node. Okay, in the third step we'll basically join the pointers that we obtained from previous step. Okay, so this the next of this m minus 1 node will actually point to the new head of this portion. Okay, so because 4 is now the new head of this portion that we just reversed. Okay, and this becomes the tail of this portion. Okay, this mth node. Okay, so its next will point to n plus 1th node. This will become very clear once I start writing code for this problem. Okay, so let's jump onto the code. Now let's start coding for this problem. The main job here is to implement this reverse between method. It takes the head of the list as an input argument and it takes two integer value m and n, which represents the start and the end position of the portion that we need to reverse. Okay, so we need to reverse the portion of the list starting at position m till position n. Okay, so first I'll create few pointers and I'll explain the purpose of these pointers while writing the code. Okay, and I'll try to name them in such a way that from the name it is evident what this pointer is pointing to. The first pointer name is m minus. Please don't bash me for not using the camel case naming convention. So basically I'm keeping these names, I'm creating these names with underscore so that they are more readable. Okay, but this in no way means that you should create variables with the underscores. You should always use camel case naming conventions while creating the variables in Java. So this is basically m minus 1 node. So this pointer will actually point to the previous node of this position m. So whatever node is at this position m, this m minus 1 node will actually point to the previous node from this position. Okay, now I'll create one more pointer. I'll actually create two more pointers after this. So m node and Okay, this, as the name suggests, this pointer will actually point to the mth node. Okay, so it will point to the node at this position, okay, at position m. Now I'll create one more pointer, okay, and this will point to, so reverse portion head will actually point to the head of the portion which we reversed. Okay, so after reversing the sub portion of the list, the head will be pointed by this reference. Okay, now I'll create one more pointer, so which will point to reverse portion so this pointer will point to the next node of reverse portion head. Okay, so this pointer will actually point to the next node of this node. Okay, so whichever node is at the head of this portion, this will actually point to the next node, and the next node before reversal. Okay, so not after reversal. So this will point to the next node of this before reversal. Okay, now let's start implementing this method. Count the number of iterations. Okay, and I'll have a variable previous which will point to the previous node. Okay, and I'll have a result variable which eventually will return. Okay, so I'm making it point to the head for now. Okay, so this will be the variable that will be, or this will be the result of this method. Okay, so for now I'm pointing it to the head node. Okay, now I'll start the iteration. Count is less than m. So what we'll do is previous is equal to head. So we change the previous pointer to point to the head. Okay, and we'll move the head to the next node. Okay, and we'll increase the count variable. Okay, now this previous will actually now point to the m minus 1 node, and the head will actually point to the mth node. Okay, so now I'll assign these two variables, and mth node will point to the head. Okay, to this variable. Okay, now the next step would be to reverse the portion of the list between m position and n position. So from m position to n position, this sub portion will reverse. Okay, so that is step 2. So for that, what I'll do is I'll write a separate method. Okay, so I'll basically say reverse list, and I'll basically pass it the mth node, because we have to start reversing from the mth node. Okay, so mth node, and how many elements we have to reverse? Actually we have to reverse n minus m plus 1 elements. Okay, so this method will start reversing the list from mth node, and it will reverse the next n minus m plus 1 nodes. Okay, so now let's create this method. Okay, so here what we will do is we will again initialize a count variable. Okay, first let me rename this to head. Okay, so this is basically the head of the sub portion that we need to reverse. Okay, so we can portion head. Okay, yep. So and then we'll basically have another this node which will point to the previous node. Okay, then we'll start iterating over this portion. Okay, so while portion head is not equal to null, okay, and count is less than equal to nodes to be reversed. Okay, so we'll basically have a temp variable. Okay, and it will point to your portion head dot next. Okay, and head dot next will actually point to, sorry, not head, portion head dot next will actually point to the previous node, because we are reversing this portion, right? So because we are reversing this portion, the next of the current node will actually point to the previous. Okay, so we are just reversing the pointer. Now in the next step we'll make the previous point to the current portion head. Okay, and then we'll basically move the head to the next node. Okay, so sorry for making the same mistake again, but portion head is equal to temp. Okay, so we reverse the pointer here. Okay, and then we made the previous node point to the current node, and we move the current node to the next node. Okay, so this is a simple reversal flow, right? Now what we'll do is reverse portion head is the previous node. Okay, so this previous at the end of this loop will actually point to the reverse portion head. Okay, and the portion head will actually point to the reverse portion head's next node. Okay, so will actually point to, so portion head will actually point to that. I forgot to increase the counter variable here. Okay, so our method is complete now. Let me now try to complete this reverse between method. Okay, so this method, in this method we'll actually now check for two conditions. Okay, so if m is equal to 1. Okay, so this condition will actually indicate the case when you have to reverse from the very first node. Okay, and let me, for better clarity, let me change the name of this variable to result head. Okay, so basically this condition will point to the case when you have to start reversing from the very first node. Okay, in that case your result head, okay, your result head will actually point to the reverse portion head. Okay, so basically now the head of your result list actually becomes the reverse portion head. Okay, because you are starting to reverse from the very first node. Okay, then mth node dot next will actually point to the reverse portion head's next node. Okay, so if you start reversing from the very first node, the result head will point to the reverse portion head, and the mth node dot next, okay, will actually point to the reverse portion head's next node. Okay, now if we don't have to start from the first element, in that case this condition will get executed. Okay, in this case what we'll do is m minus 1 node dot next will be reverse portion head. Okay, so the next pointer of m minus 1 node will point to the reverse portion head. Okay, and mth node dot next will point to the reverse portion head's next node. Okay, and then we can easily return result head from this method. Our code is complete now. For validating this code, I submitted it on LeetCode web portal, and I'm happy to inform you that it is faster than 100% of the Java solutions submitted on LeetCode. It is one of the most commonly asked problems when it comes to coding interviews. I'll check in this code into my GitHub repository and will provide a link to my GitHub repository in the description section of this video. I'll also provide link to the coding portal where we can solve this problem. If you like the content of this video, please give me a big thumbs up and please subscribe to my channel. It gives me a lot of confidence when I see new users subscribing my channel. I'll soon come up with a new video on problems frequently asked in coding interviews. Till then, keep practicing and keep learning. Goodbye for now.